Okay, exponents. We are doing 8.1 products and powers. Y'all better pay attention. Blair, start writing. Okay, so products and powers is what we're talking about today. Very basic. So let's do a quick review. If I have 4 to the second power, is that answer 8?
No.
If I'm asking you that, you know it's a loaded question. You know that the answer is no. What'd you say, Valeria? Yeah, that's right. It's 16 because that means it's 4 times 4. So we all know a very common mistake is 4 times 2. Even you guys, I've seen adults when they're just working, and again, you're so focused on the rest of the stuff that I'm going to teach y'all today that you will make mistakes like that. How about 5 to the third power? Is that 15?
No.
That is saying 5 times 5 times 5.
125.
I'm waiting for a consensus here.
It's 125.
All right. So now that we kind of remember how we use just exponents, we can move on. Okay? So we good? All right, let's go. First thing we're going to talk about is the properties of exponents. Some of you got this really well last year, and some of you are, oh man, I don't like this. First one, the product property. What does product mean? Answer to a multiplication problem. You know what this is saying? And sadly, like I don't go into too much detail in Algebra 1 because it's, you're supposed to have already learned it. Product property says if the bases are the same and you're multiplying, does anyone remember what you do to the exponents? Okay, next time raise your hand. But yes, Miranda, you are correct. You add the exponents. That's correct. So those of you that didn't have this last year, if the big number or letter is the same, the exact same, like if this is 4 and this is 4, or this is B and this is B, and you're multiplying, then you add the exponents. Those of you that had me last year, do y'all remember this?
Yes.
If you're like, no, I don't, it's okay. Huh? Did we do this year?
Yes. At the beginning.
Are you serious?
Mm-hmm. At the beginning of the year.
Are you serious? All right, I'm gonna.
Division, subtraction.
Yeah. All right, I'm stupid. Okay. Well, then that's why I don't have any notes, and y'all should ace this then. Okay. So then the power, then I can really move fast. I was wondering, okay, I'm losing it now. It's official. Okay, the power property. I'm so glad y'all remember this. So if I have x to the power of a to the power of b, raise your hand if you remember what do you do with the a and the b, chap?
You multiply.
That's right, you multiply them. Okay, so if ever you have exponent on the inside of the parentheses and one on the outside, you multiply them. Oh, that makes me feel so good. Okay. That y'all have already learned this, not that we just did a math problem. Okay.
Probably both.
Yeah, because I like math. Okay, so we're going to just do a bunch of examples now.
Yay.
All right. So 3x squared times 5x.
That's already an answer, right?
That's not the answer.
Oh wait, I'm sorry.
We're
Oh wait.
Chad, chat. Franz, I absolutely love you in my class and you sitting right here because you just keep me laughing all day long. Okay, if multiplying, what do we do? If the bases are the same, see the two x's?
Add.
We add exponents.
Wait, is the 3 or the x?
We're looking at just the x right now.
Oh, okay.
See that if the bases are the same and we're multiplying, we add the exponents. So, question, what is 3 times 5?
15.
And x squared times x. And oh, by the way, if we don't have an exponent here, what do we pretend is there, Valeria?
1.
There you go. We pretend there's a 1 there. So then x squared and times x to the 1 would be, let's see, Sophia, what would it be?
2.
Huh? If the bases are the same and we're multiplying,
Sorry, I thought you multiplied
3. Okay, so look at this again. 3x squared times 5x. We multiply the numbers like normal. These are your bases. X squared and x to the 1. If we're multiplying and the bases are the same, we add the exponents. Does everyone see that? Yes.
When the exponent is 3, isn't that cubed?
Yeah, it doesn't matter.
Okay,
We
I
just say
was just gonna ask because I was wondering.
at this point, because we're gonna have that we're beyond just 2 and 3. So it's just to the power of 3, to the power of 5, to the power of 10, because we're gonna be getting the big numbers. Okay, so that would be your answer. Now we've been, if you were adding this, like Franz said, in that the answer, if we were adding or subtracting, that would be the answer because of combining like terms. You could not combine these. But when multiplying, we absolutely can. So does this make sense?
You can combine it with the bases the same.
When you're multiplying. But if you're adding and subtracting, that is x squared and that is x to the 1, so you could not combine them. Okay? Okay, good. Another example. -8x squared y z 3 times x y z squared. Okay, write that down.
Z cube.
What?
That's Z.
Which one?
That's Z, right?
These are z's.
Z is what? Z is
Z2, Z3. Okay, so my first question, I'm going to cover with a tardy slip this portion right here. That is one big term. That's one term. Like up here we have 2 terms, right? This is one big term. But within this term, what are all these things doing? What operation is taking place with all of them?
multiplying.
That's right. They're all really multiplying with each other, right? Now, if I take that whole term and multiply it with this term, -8, are there any numbers over here? So then, who wants to guess how to do this one? Franz, you want to guess the answer?
I'm guessing you do like the 2 exponent from the.
Let's do the number first. -8 times whatever's over here.
It's gonna be -8.
It's going to be -8. Now, let's look at the x. I have x squared and then x. Are we multiplying, boys and girls?
Mm-hmm.
Are the bases the same?
Mm-hmm.
So what do you do to the exponents, Franz? That's right. So then it'd be -8x what?
2 squared.
Whoa.
Wait, no, 3. Cube.
One person talking.
Cube.
That's right, because we have a 1 there, so it'd be x cubed because we're adding. Franz, what would be the y?
Squared.
That's right. Because the y's, the bases are the same, we're multiplying. So it'd be 2, because remember, we pretend that there's a 1. And then z to the what?
I was wondering if it were to be multiplication.
If okay,
I know.
the bases are the same,
Yeah.
and we're multiplying here, right? So what do we do the exponents?
You add them and it's 5.
There you go. Good job.
I was wondering if the exponent, since there's one exponent in the box and then one outside the box, would it be multiplying? I was wondering that.
No, because the exponent is not attached by itself to the parentheses. Like, see right here? He's asking, he's confused. He was wondering if you multiply because there's an exponent on the outside of the parentheses and there's an exponent on the inside. But you only multiply if the exponent is attached to the parentheses. These exponents are attached to the individual letters. So, are there any questions about this problem, chat?
How come you wouldn't? You said it's all one term, or like the 4.
This is one whole term, yes.
But then how come, like, you separated the 3 from, like, in the first example, you separated the 3 from the x squared and the 5 from the x?
Oh, I'm just saying, I'm drawing your attention. It'd be like 3 times 5 is 15, and then x times it.
Okay.
It's the same thing. 3x squared times 5x would give you that. I was just separating to draw attention to
I
it.
have another question.
Okay, go ahead.
If you have a 3, you know that 3 on the end, the z, attached to the z? Yes. If that, like, take away everything else to the left of it, would you multiply that, or does it have to be on the other side?
It has to be on the other side. So, Franz, that's kind of going along with your question. He said if all of this was gone and this is all that we had, he goes, then would you basically multiply it? Yes, technically you would, except for the fact it's in the wrong position. So it's like floating in air. If it's over here, like right here, it's attached to that. Does that make sense? These are good questions. New.
What if instead of z and it's a number, would you multiply it as distributed properly to allow it to increase indices?
Like, if it was just this?
Yes. What if the z is a number?
Well, it would work except for the fact that this is one whole term.
Is my water in here?
I threw it away because I wasn't sure whose it was.
Okay,
And it had just this much left.
Okay, that's fine.
Okay. Oops. He can dig it out of trash. You think he wants to dig it out of trash?
We don't drink water anyway.
Okay. All right. So it would be distributive if these were by themselves, like x plus y plus z. Then you would multiply each one. But because this is one whole term, you're basically multiplying it and it combines with the z.
So, what if you have 2z cubed,
Right here?
like in the z cubed? What if you have another 2 before z? And do you add the exponent of the z together?
Just the z's. Just the z's. Yes.
Would you take it away from the 2, or would you just...
I think you are thinking way too much into this. I really do. It's just straightforward. I really think you're like thinking way more into this than you need to. Let me answer Morgan's question. Let's do some more examples. If at the end you are still asking these deep questions that are trying to stump me here, then we can go with that. But I think y'all are going to be happy once we do some more examples. Yes.
Why are you splitting it up, like, kind of like Chad said, but it's one, all of it is one thing, right? Like 8x
Yep.
to the power 2. Why? Because usually with distributive property, which is what it looks like.
It's not. This is what it'd be like. This is what we're doing.
Right. But why?
Because you're
Isn't
looking
it the
at
same thing?
it is. But I'm focusing on -8. Is there another number over here? No, there's not. So it's
you can't multiply it, but wouldn't you, like, why
We-
wouldn't you multiply all of the numbers in the parentheses by, like, the whole
We
equation
are.
instead of...
we are. This is exactly what we're doing. We're multiplying this whole thing with this.
But,
And this is the answer you get.
but then you would have a lot more numbers.
No, you wouldn't.
If you took all of that and then multiply it by only x, and then all of that and then only
No, that's what New was saying. And I said if these were separated, then you would do the old fashioned like. If you did that, then this would be x squared plus xy minus xz. Isn't that what you are saying? But we're separating it with a plus and a minus. All we're doing is taking this term, it's just like this, and multiplying it by this. Okay? I'm telling you, y'all are thinking way too much into this. We're going to be doing lots of examples now. All right. Let's look at this problem. There you go. There's the outside of the parentheses 1. Okay, now, again, every time you see a letter without a number or an exponent, we want to pretend that there's a 1. In this case, I know when it comes to stuff like this, you guys know that. And you don't have to always write a 1 in place here. It is very helpful to do it. It's like Mrs. Rogers' tip of the day. It will keep you from making those mistakes, especially in this situation. So you're going to want to put a 1 here just to make yourself happy. Now in this case, if you look back here to the power property, when there's an exponent on the inside and 1 on the outside, what do we do with them?
multiply.
Multiply. So in this case, we're going to be doing that. There's a 3 on the outside of the parentheses for your exponent, and then on the inside. So what are we doing? We're multiplying it with all of this. Everything on the inside of the parentheses. So your answer is negative a to the 3rd power times b to the 6th power. Now, sit back, look at that, and tell me if you understand this. I know y'all have questions. What if it looks like this? What if we do that? What if this is in place? Well, I got it. But let's start with the basics and make sure we understand this. Are there any questions about this? Are y'all just sitting there quiet because I said something, or y'all really get it?
I get it.
Okay, Miranda, you get it? All right. So we're going to pretend there's a 1 there when there's no 1. Okay, where there's no number. Here's another example. Oh my gosh, this is going to freak some of y'all out. I see it now. So pay attention. Negative 2m to the 4th power times n, in parentheses, to the 3rd power, times 1/6 mn squared, all to the 2nd power. Don't freak out, Franz. Don't stare at me like that. I'm telling you, it's going to be okay. Do exponents with parentheses first. And keep your letters in ABC order as much as possible. It won't give you a wrong answer, even on the test, but it just makes sense. Okay, so we're going to do the exponents with the parentheses first. So this exponent, Keith, you pay attention? This exponent is applied to everything in the parentheses. Please make sure you have good notes. Yes, sir.
How come there are 3 things?
How come there are three things?
Yes.
Be
like,
more specific.
Like in one of the other ones, like I think it was like the second one, you said that was a whole term.
This is a whole term, this is a term.
Okay, so then why are there three things that the exponent is being multiplied?
Are you talking about these three things?
Yes.
Why are you multiplying the numbers by the exponent?
You're applying it.
But on the
Why do you
Watch.
at the top,
That's with exponents.
that's
Watch,
Yeah,
watch,
well,
watch.
that's what
No,
she-
you're going to watch. You're applying this to everything in here, correct? Watch. -2 cubed now. And what do we do to the exponents when they're on the outside and inside? What do we do with them?
That's to the
Ah, so 4 times 3 is?
12.
See, exactly. That's why I said hold your question.
Four, not the
N, so 3 times 1 is what, Morgan? Very good. Now, the 2 is being applied to the 1/6. It's applied to everything. Look, it's now squared. 2 times m1 to the first power would just give you squared. And then this 2 is being multiplied with this 2, so what's in, Valeria? Look at you go. Now, does that make sense?
No.
What
Kind
part
of.
does not make
It
sense?
does not make sense that you multiplied the number as well.
I didn't multiply the
I
number.
know that you applied the exponent to the number as well.
Yeah.
To the top, you didn't apply it to the x.
What X?
You applied it to the a, but you did not apply it to the x. So wouldn't it be
Look. This is the base, right?
right?
I did apply it to the exponent, right?
Right.
Let's focus on the m. Did I apply it to its exponent?
Mhm.
Just like right here, right?
Right.
The -2 is the base. Pretend, how about this? Would this help you? Let's put a little 1 there. There's no exponent, right?
Right.
What's 3 times 1?
3.
Boom.
Right.
Now do you get it?
Kind of. But
You're applying it to every single little thing in there.
we go back to the x thing. But the x is the base and the number like on the bottom.
That's just your base.
right on the bottom of it. Go back. Go back.
I love y'all, just want y'all to know.
The 2 is the base, but an m is the base as well, right?
In the N.
And the n, they're all bases.
Yes, ma'am.
Okay, now I get it.
Okay, good. Anyone else have questions? Yes, Chad? And just know, if y'all are purposely asking questions to prolong, I'm still assigning work whether you have independent time or not.
I'm not doing that.
Okay,
How
ask
dare you.
legit questions. Okay.
Okay, so you know how they said like I'm still stuck on it, but like you know how you said that they're like one term?
This is like one term.
What the heck is a term?
We've already learned that. I'm sorry, you'll have to go back and read. Go ahead.
How come you don't just multiply the exponent by the exponent of the term?
You're doing it to everything in the parentheses. This one, and this one.
I get that.
This one,
and
this one, and this one.
I get it. I know how to do it.
Well, then why don't we move on?
Like it's one term, so then how come it's not like one number? So then you
Because there's several things
that whole
inside
thing's
this.
the base.
There's several things in there. This, it's in parentheses, so this is being applied to everything. If you were to take the parentheses away, then it'd just be N3 is what you're saying. And then all these would stay the same. So this is being applied to everything inside that term.
Okay.
You are still reading too much into this. So what is -2 cubed? Anyone? Thank you. We're still working out. What is 1/6 squared? That's right. It's 1/6 times 1/6, which should be 1/36. Now, these are all being multiplied together, correct? So, what is negative 8 times 1 over 36? We're going to do those first. So, negative 8 over 1 times 1 over 36. What do we get?
Negative 8 over 36.
Can you reduce that?
2 over 9.
Negative 2 over 9. Very good. Because it would be negative 8 over 36, and then we reduce it. So M, here we have, now let's do our M's. M's the base, the bases are the same. We're multiplying. What do we do to the exponents? So then what would M be?
14.
M, 14. What would N be?
7.
That's right, 7. Because we're multiplying, the bases are the same, so we add the exponents.
How is M 14?
Because it's M12 and M2. If you're multiplying and the bases are the same, Miranda, what do we do to the exponents?
Yeah.
There you go. So 12 plus 2 is 14. And then if you look at N, bases are the same. They're being multiplied right here. So we add the exponents. 4 plus 3 is 7. Okay, we're going to do a lot more examples. Last year, group
Last year was 29
didn't
days
need
ago.
any examples, but
Last
we're
year was
doing
29
examples.
Last year was 29 days ago.
Last year's group. Okay, so let's start with number 1. We're looking at page 330. Yeah, we're doing a lot of examples today. A lot. By the time we're done, y'all gonna be able to do this in your sleep. We have x cubed times x to the 5th power. Miranda, you're my first victim.
That would be X.
There you go, x to the 8th power. Because the bases are the same, we're multiplying, so we add the exponents. Very good. Ooh, look at number 3. X squared times y cubed times x to the 5th power times y squared. Oh, I like that one. New. X to the 7th power and y to the 5th power. Because the bases are the same, you multiply and add the exponents. Does anyone have questions so far? Good job. Now, because y'all are all, what if you wrote it like this and switched the letters? Technically, it's not wrong. It really isn't. But you really need to put them in ABC order to be correct. Next year, if y'all go somewhere else or have a different teacher, they may say, oh, that's wrong. You never know. So it's a good habit, but no, I am not going to mark it wrong if you don't put it in ABC order. I'm more concerned as, do you understand this? Okay, let's do another. 3w to the 3rd power times 4w to the 4th power. Let's see, chat.
You get 12W to the 7th power.
That's right. People always want to, because you just multiply the 3 and the 4, it's very common to just go ahead and do 3 times 4. That's common. Just you got to be slow and precise. In this case, with the w's, the bases are the same. Since you're multiplying, you add the exponents. All right, 7. Ariel. A to the 4th power to the 3rd power.
A to the 12th power.
Very good. Because We're multiplying. This 3 is being applied to the exponent of that base. Any questions so far? All right, let's look at number 9. Keith, you're my next victim. I have c to the 5th power times c to the 2nd power to the 4th power. So my question is, which one are you going to do first? Are you going to do the c to the 5th power times this one? Or are you going to use this, mess with this little exponent here first? That's right. You're going to do this first. Do the one associated with the parentheses first.
How come?
Because that's the rule. PEMDAS. Which do you do first? Multiplying or
Parentheses.
exponents?
Parentheses, exponent,
So we're going to do this first.
division.
Okay, so Keith, what do I do with this? It's being applied to this. What do I get?
C to the
That's right. Now, Keith, the bases are the same. What operation are we doing here? So what do we do to the exponents? Do what? That's right. So what do you get? C to the 13th? Perfect.
Wait. Wait a second. Oh, you're multiplying. Never mind.
Okay, Miranda?
Wouldn't that be 4 times 4? So we'll
Where do you
just-
see another 4?
Well, the 2 and the 4, you have to multiply.
4 times 2. Okay, I see the look on your face. You get it.
Wait. Why are you multiplying when it's outside the parentheses like that, but not when you're multiplying both things?
When it's on the outside, you multiply.
Right, yeah, but
Right here, you're multiplying 4 times that 1 exponent. I mean, 3
there's two
times that
types of
1.
multiplying.
3 times that 4.
Wrong.
3 times that 1. See what I'm saying?
Yeah, but there's 2 types of multiplying. It's weird.
Where do you see 2 types of multiplying?
Because then there's multiplying where you're just regularly multiplying.
We're
x.
but that's the
X.
bases. We're doing
Right.
bases and exponents.
Right.
Okay. Yes, Miranda?
Why isn't it 2 or 4? Because there's a 2. So when you multiply the 4 by the 4? 4.
What for? There's
Is it on top, like above the title?
That's 4 to the 2nd power, 4 to the 2. That's a big 4.
Never mind.
okay. More examples. Let's look at 11. Good job, Keith. -2 times b squared times c times d to the 5th power all to the 2nd power. Morgan, you're my victim.
Yay.
So what am I going to do with this exponent on the, first of all, is there anything I can combine inside the parentheses? No, correct. Good job. What do I do with this 2?
Multiply it by everything.
The bases?
Everything. Yeah. All the exponents.
Bingo, you said it.
And
The
there's
exponents.
that includes the invisible exponents.
That's right, includes the invisible exponents. Good job. Our invisible ones are 1. So we're going to apply it to that 1, to that exponent of 2, to that 1, and that 5. Good job. So then what's your answer?
-2 to the power of 2 times b to the power of 4 times c squared times d to the power of 10.
And what is -2 squared?
4.
So we have to complete it. And that is perfect. Good job. Now write that down and you guys take a look at it. Making sense? All right. Let's look at 13. We're moving on. Simplifying. I have 2a squared times -5b cubed. Valeria, you're my victim. So there's no exponent on the outside. So we just start multiplying this whole thing with this whole thing. Go ahead, get started. What's the first thing we're going to do? That's right. Multiply the 2 and the -5. What do you get? That's right, -10. Good. Can A, now here's going to be like new, and a lot of y'all were asking, A squared times the rest of this. Is there any base that's the same in either term?
No.
Is there? So then it's just A squared B cubed. 2A squared times -5B cubed is just -10 A squared B cubed, because there's nothing that this is combining with. There's not another A in there, or there's not a B out here, so we can't combine them. We can just rewrite them. Let's do 15. 4ABC times -3A cubed BC. Sophia. Mm-hmm. Perfect. There you go. Because these are all ones. There you go.
Would you have to put a 1 with a 4 and
Nope. This is making more sense now. All right, let's do another one. 5x cubed, and that's cubed, times 2x squared. Franz. Let's do the exponents on the outside first, and what are they being applied to?
So
Well, you should have been paying attention. Miranda, you're my victim. So the 3 is applied to this and that, and the 2 is applied there and there. So what do I get, Miranda? No. There you go. Okay. Times.
2 to the 2 to the second power,
Good.
and x to the second power.
Good. So what is 5 cubed? Anyone want to help her out? 125 x to the 9th power times what's 2 squared, Miranda?
4. No, 4.
Yep. And x. Now we multiply. Anyone want to tell her what 125 times 4 is?
500.
You're correct. And then Miranda, what's the x? What would your x be?
18.
Nope. If the bases are the same and we're multiplying, you.
So 11.
Very good. Any questions? All right, I'm going to do one more. And I'm setting you free. Look at 23. 3b squared cc minus c squared b plus 2b c squared. Franz, you want to try this one? You have it written down? All right, Franz, you're supposed to be taking notes. New. You're my next victim. All right, guys. How many terms do I have here, New? That's right. So, Miranda, look. I have 3 terms. 1, 2, 3.
So are they just a different grouping?
That's right. Exactly. Because we're subtracting and adding these 3 groups. So, New, let's combine within our groups first. Is there anything I can combine in this group? In this one right here.
Wait, you can't combine the two C's.
Ah. New, can I combine those 2 C's? Aren't these all being multiplied? So what's C times C? Ah, so it's 3b squared c squared. New, can I combine anything in this group? No. Can I combine anything in this group? What do you get? Excelente. Now, we are adding and subtracting. Are all of these, what we're doing is we're combining like terms. That's what we're doing. We're combining like terms. So let's look at these 3 groups. First of all, are all these letters in ABC order? Not the middle one. Correct. So we're going to rewrite that in ABC order. Each term. This one's okay. This one, the B needs to go first. And this one's okay. Now, New. Look at your 3 terms. Bingo. The first one and the last one can be combined. I have B squared, C squared, B squared, C squared. So they absolutely can be combined. We're only adding and subtracting, so these exponents won't change. So what do I get, New?
5b squared c squared minus b squared bc squared.
But couldn't you also do the middle one because you've got to be
They have to be identical. These are your like terms. B squared, C squared, B squared, C squared. And you can't go any further. This is your answer. Excellent. Any questions? All right. I'm going to write this so people that understand can get started. And then the rest of you that have questions, I'm all yours. You're going to do 2 through 24 even. Everyone's going to do the same problems because it seems to be challenging for everyone. This is due Friday.
Why wouldn't
Uh-huh.
why wouldn't you add